Hello students, I'm Masika Michael, a teacher of chemistry at Nasokor Girls, and today I'm going to teach the topic of reaction rates, and the subtopic is effect of change in concentration on position of equilibrium. As you all know, this topic is based on Le Chatelier's principle. And just to state Le Chatelier's principle, because we are going to apply it in explaining how concentration affects the position of equilibrium. Le Chatelier's principle states that when a change in condition is applied to a system in equilibrium, the system moves so as to oppose that change. Now, that is just stating that principle. But now, the most important part of that topic is, or of that subtopic is, application of Le Chatelier's principle in explaining the effect of change in concentration on position of equilibrium. Now, we are going to use this question to see how change in concentration is going to affect the position of equilibrium. Now, the question here is that a solution of bromine gas in water is an example of a reaction in a state of balance. The reaction is represented by the equation below. Now, look at this equation. This equation has bromine gas reacting with water to form hydrogen ions and bromide ions and OBr. And when you look the at the bromine is in water is yellow. But now the same bromine after the mixture of bromine and a yellow solution and a colorless solution. Now, we want to see state and explain, state and explain the observation made when number one, dilute hydrochloric acid is added. When you add dilute hydrochloric acid to this system. Now, first of all, students, you must ask yourself when you add hydrochloric acid to this system, to this equation, what are you doing? When you add any acid, hydrochloric acid being an example, hydrochloric acid, let me just write here, consists of HCl and in water it ionizes to form hydrogen ions and chloride ions. So you find that hydrochloric acid has hydrogen ions. So when you add hydrochloric acid to this system, it's like you're adding hydrogen ions. And when you add hydrogen ions, you are going to increase you're going to increase the concentration of hydrogen ions. You are going to make the concentration of hydrogen ions to go up. And now, when the concentration of hydrogen ions increases, this disrupts the equilibrium. This disrupts the equilibrium because now you have put more hydrogen ions on this side, and therefore the backward reaction is going to be favored so as to reduce the concentration of hydrogen ions and re-establish equilibrium. And therefore, if you have been asked to state the observation made, state and explain, your answer, you must start by stating the observation before you explain. Now, here, the first thing that we do, we state the observation. And since the backward reaction is going to be favored, it means more of H positive, Br negative, and OBr are going to combine to form H2O and Br2. And since Br2 is yellow, so the observation made is that the intensity of the yellow color increases. That is the observation that is going to be made. Now, after stating the observation, now explain that observation. Now, to explain the observation here is that now addition of AHCl or any other acid like H2SO4 or HNO3 increases the concentration of hydrogen ions. And now, because of that, the backward reaction is favored. Now, that is how you are supposed to respond to that question. Now, let's look at another part. Suppose you are told that to state and explain the observation made when sodium hydroxide solution is added. Sodium hydroxide solution is added. Now, we need to ask ourselves, when you add sodium hydroxide solution, what are you doing to that system? So we need to understand the chemistry of sodium hydroxide. Now, you need to know that sodium hydroxide solid, when you dissolve it in water, When you dissolve it in water, it's going to ionize to form sodium ions and hydroxide ions. Since water is polar, the sodium hydroxide is going to ionize to form sodium ions and hydroxide ions. Now, looking at this system, when you add sodium hydroxide, it's like you're adding hydroxide ions to this system. And when you look at the whole of this equation, the only thing that can comfortably react with hydroxide ions is the hydrogen ions. So when you add sodium hydroxide solution to this system, it is like you are reducing the concentration of hydrogen ions because the hydroxide ions in sodium hydroxide are going to react with hydrogen ions to form water, and therefore the hydroxide ions are going to, in this case, are going to reduce. They're going to reduce the concentration of hydrogen ions. And when you reduce the concentration of hydrogen ions, it disrupts the equilibrium, and therefore the forward reaction is favored. The forward reaction is favored so that now more of bromine and water can combine to form hydrogen ions and increase them because they had been reduced by addition of hydroxide ions, and therefore the forward reaction is favored. And since the forward reaction is going to be favored, bromine, which was making this solution yellow, is going to reduce, and therefore the yellow color of the solution fades. And since we must start by stating the observation before explaining, we write that the yellow color of the yellow color fades. The yellow color fades, and that is because hydroxide ions neutralize the hydrogen ions and reduce their concentration, and therefore, hence the forward reaction is favored. Hence, the forward reaction is favored. That is why that is what is going to happen when you add a basic solution to this system. Now, let's look at a different example, a different system. Suppose you consider a system that consists of dichromate, and this one is chromate. This one here is chromate because it has only one chromium. So this one is chromate. This one is chromate. And this chromate is yellow. And now the dichromate, this one is dichromate because it has two chromium. This one is dichromate. This one is dichromate. Now, suppose you are asked a question like this one that states and explain the observations made when dilute nitric 5 acid is added to that system. Now, we need to understand again the chemistry of dilute nitric 5 acid. We find that dilute nitric 5 acid, just like other acids, consists of hydrogen ions and nitrate ions, and therefore addition of nitric 5 acid is like you are adding hydrogen ions to this system. So that one is going to increase the concentration of hydrogen ions, and therefore when the concentration of hydrogen ions is increased, it disrupts equilibrium, and therefore the forward reaction is going to be favored, or rather equilibrium position is going to shift from left to right, or the forward reaction is favored. And therefore, for that reason, because we have been told to start by stating the observation, since the forward reaction is going to form the dichromate, which is orange, we start by saying that the observation is that equilibrium mixture becomes more orange. And now the explanation is that now addition of nitric 5 acid increases the concentration of hydrogen ions. Hence, the forward reaction is favored. That is when you add an acid to this particular system. Now, students, suppose to the same system of involving the chromate and dichromate, you add, now this time round not an acid, but you add ammonia solution to the system. What is going to happen? We want you to state and explain the observation. Now, in this case, looking at the system, when you add ammonia solution, we need to understand that ammonia solution is actually ammonium hydroxide. And ammonium hydroxide consists of ammonium ions and hydroxide ions. Now, hydroxide ions are the ones that make a solution to be said to be basic. So when you add hydroxide ion, ammonium hydroxide is going to introduce hydroxide ions to that system. And looking at the system, the hydroxide ions now are going to neutralize the hydrogen ions and reduce their concentration. So the concentration of hydrogen ions is going to go down because they have been neutralized by the hydroxide ions. And by so doing now, the backward reaction is favored. And since the backward reaction is going to be favored, the equilibrium mixture is going to become more yellow. So when you start by stating the observation, is that the equilibrium mixture becomes more yellow. And the explanation for that is that now the hydroxide ions from ammonia solution neutralize hydrogen ions. Hence, the backward reaction is favored, or equilibrium shifts from right to left. Thank you, students, and welcome to my next video, in which I will be sharing about effect of change in pressure on position of equilibrium.